So I want to start you off this year with something that I'm going to do fairly frequently, which is very often it's important to have a video to either introduce a topic or to solidify a topic or to give some extra examples of a topic. And so today what we're going to do is we're going to watch a video, and I'm not going to require you to take notes on this, but it is important. It's important that you know what's going to happen tomorrow during class and be able to follow along without just taking dictation over the notes. So today we're going to talk about the real numbers. And the real numbers are all of the numbers that we're going to work with in this year. Real numbers are those numbers that you can put on a number line, that you can put a dot on a number line, and will definitively show you where that number is on a number line. So we're going to start by categorizing all of the real numbers. So if we look at this diagram, we can see that these are all of the real numbers. And included in these real numbers are all of these subsets. And we're going to start from smallest to largest, and then we're going to go ahead and graph some of these on our number line. So we're going to start in the middle here with the natural numbers. Natural numbers are exactly how they sound. Their natural numbers are like what a toddler would count when they start learning how to count, and they'd start counting like this. 1, 2, 3, 4. What that does not include is 0 or any of the negative numbers. So it's important to know that natural numbers are those basic whole numbers or counting numbers. We're going to go out to the next category right here, which is the whole numbers. Now, whole numbers include all of the natural numbers. So they include 1, 2, 3, 4, 5, 6. These 3 little dots means that it goes on forever. And here we're going to include the number 0. 0 is a very important number in mathematics, and we're going to be using that a lot. So that now includes the number 0. Going out to the next category, we're going to talk about integers. And integers, very frequently when we hear the word integers, we think about all negative and positive numbers. But integers are a very specific group of numbers. They are the negative and positive whole numbers and 0. So you'll notice that that includes all of the natural numbers, all of the whole numbers, and then we start counting back by negatives in whole numbers. So integers are any negative or positive whole numbers and the number 0. So 0 is considered an integer even though it's not negative or positive. We're going to take that from the integers all the way out to the rational numbers. Now, rational numbers are every number that we're going to be working with in this class. For the most part, is going to be a rational number. A rational number can be written as A over B. So we could have -1/2, we could have 2/3. We could also have something like 4/100. Now, that right there is not written as A over B, but you could write that as 4 over 100, which means it is a rational number. Now, all negative and positive whole numbers are rational numbers, because if I take the number 9, I can write that as 9 over 1. So those are our rational numbers. Any number that can be written as A over B. Okay? Irrational numbers. Now, irrational numbers remind me about talking to an irrational human being. Sometimes they go on and on forever, and you don't know how to follow their story. Well, irrational numbers are not very different. Irrational numbers are those numbers that their decimal never repeats and never terminates. And that's a little difficult to understand. So let's look at the difference between 1/3. Okay, 1/3, if I put that in my calculator, I'm going to get 3, 3, 3, 3, 3. And I bet you can predict what's going to come next. It's going to be another 3. So we can write that as 3 with a bar over it. So it does repeat, okay? And so as long as you can tell what's going to come next, then it's a rational number. There are a few numbers that do not repeat and not terminate. So if you were to put the number pi into your calculator, you would get 3.14, but none of these numbers Could you guess what the next number is going to be? They're non-repeating and non-terminating numbers, and that's going to be a rational number. The last category of numbers are imaginary numbers. We will not be dealing with imaginary numbers in this class, but you will start working with imaginary numbers in your Algebra 2 course. The most famous imaginary number is the square root of -1, which is known as I. Pretty much the most famous imaginary number. So we won't work with that in this class, but they do exist and mathematicians do use them. So let's look at what it would be like to graph these numbers and do some examples. We're going to lead from graphing just some of these numbers into graphing some what's called interval notation, which means we're going to be graphing a set of numbers. So let's start from the beginning where we started talking about natural numbers. And let me just give you one example. Let's say that we were going to graph the natural numbers between -6 and 4. I don't think I really needed a comma there. All right. So we're going to graph the natural numbers between -6 and 4. The first thing we need to do is go back and say, well, what does it mean to be a natural number? Remember, those natural numbers are those counting numbers. 1, 2, 3, 4, 5, 6, 7, on and on. So let's look at, if we look between -6 and 4, what are the numbers in between there that are natural numbers? When we look, we know we're not going to use 0 because 0 is a whole number, not a natural number. You never hear a 2-year-old start counting and saying 0, 1, 2, 3, 4. So the natural numbers are going to be 1, 2, 3. Now it says between. This means that it does not include -6 and 4. Those are the ones that are between. And we would write this in what's called set notation. And this is using these fun little brackets, and you'll get really good at these during class. I'll show you a really good technique during class to write these. But in between the natural numbers, in between the numbers -6 and 4, there are only 3 natural numbers, and those would be 1, 2, and 3. And that's how you'd write it, the set of numbers of 1, 2, and 3. Let's do another one of these using whole numbers. So for this next one, we're going to talk about the whole numbers. So we're going to say, let's say the whole numbers between 1 and 7. We're going to add a word here, inclusive. And inclusive means to include. You can kind of see that in the prefix. Okay, so we're going to look at the numbers between 1 and 7, and we're going to look for those inclusive whole numbers. Well, 2 is a whole number, 3 is a whole number, 4 is a whole number, 5 is a whole number, 6 is a whole number, including 7. That word inclusive means that we're going to include the number 7. So we're going to write this as the set of numbers of 1, 2, 3, 4, 5, 6, and 7. Now the next one we're going to go over is going to have the real numbers. And there's going to be some new notation here, and I'm going to explain to you what all of that means. But why don't we say the real numbers greater than -2 and less than 4. So pay really close attention here because we have two different things. We have greater than and less than. Okay? Greater than and less than are going to have what are called parentheses above them. It means that we want the numbers that are greater than -2, but they're not going to include -2. And we want the numbers that are less than 4, but don't include 4. So we can do that by putting a parenthesis over -2 and over 4. Now, because all of the real numbers in between are anything we can graph on a number line, we're going to create a solid line in between them. That means that if I went to 2 and 7/8, whoops, sorry about that. If I went to 2 and 7/8, right about there, that's going to fit in. That's a real number that is greater than -2 and less than 4. And the parentheses say, I'm not including -2 and 4. Let's look at one that does include the numbers. So in this one, we're going to do a little bit of a combination. I'm going to say that this number, let me grab a pen here, this number is going to be greater than, let's say all real numbers, and all real numbers have a cool symbol. It's 2 lines with an R going through. This symbol means all real numbers. So let's talk about all real numbers greater than or equal to -5 and less than 3. Now, we know that this less than 3 and greater than or equal to need to have some sort of different symbols so that we can recognize if it includes -5, if it doesn't include -5, if it includes 3, if it doesn't include 3, because this one says that it's greater than or equal to, we're including -5, so we're going to use what's called a bracket, okay? And less than 3 is going to use our same parenthesis. That's our first step. Let's put a bracket over -5 and a parenthesis over 3. And we want all the real numbers in between there, so we're going to put in all those real numbers. Now, if we were to write this in what's called set notation, we would look exactly at the graph. We know we're going to have a bracket and a parenthesis. We're going to start that at -5 and 3. These have to be in the exact same order as the graph. And what this literally says, whoops, what this literally says is all real numbers greater than or equal to, because of the bracket, -5 and less than 3. So this is what's called interval notation, and we're going to be working with that a lot this year. Now we're going to do something a little fun. I like these a lot. So we're going to deal with, grab that pen again, all real numbers less than 4. Okay, so we look here, less than, is that going to require a parenthesis or a bracket? Well, it's less than, so we're going to have a parenthesis. So let's go ahead and put that parenthesis over 4. Okay, and now we're going every single number less than 4. So this is going to go all the way across, and even though there's an arrow right here, we need to draw our own arrow because this is part of our graph. This is every number less than 4. And if I were to make you draw a graph of every single number, that would take up a majority of our year, and I'm not going to do that. So we're going to do this in interval notation, and we're going to look exactly at the graph. So the graph starts here at 4, and it goes back, and it goes back forever and ever and ever. And when we deal with forever and ever and ever in mathematics, we use what's called infinity. And that is kind of a sideways 8. But this is not just going to infinity. This is going to negative infinity. Now, here's where we have to decide. Do we use a bracket or do we use a parenthesis? Well, in order to use a bracket, we need a spot where we can include it in our graph. And there is no way for us to actually put a dot on infinity. So we're going to close that with a parenthesis. Through the magic of technology, I have one more problem up here. I'm going to go through it very quickly. All real numbers greater than or equal to 0. I know that I'm going to have a bracket here at 0. I'm going to go greater than all the way to infinity. Make sure you have this arrow, even if there's one on your graph. And I'm going to write it out. the bracket starts at 0, it does include 0.